Welcome to this lesson on shapes, three-dimensional shapes to be more specific. So we're moving from 2D into 3 dimensions, and probably most of you have seen this at some point. So it's not brand new, but there'll be some new terminology and new concepts that we look at here. All right, so we like to look at two things with respect to 3D, and that is we like to look at surface area. I'm just going to highlight these things, and surface area, and of course volume. Okay, so when we were looking at perimeter, the surface area kind of takes perimeter over, and then we look at volume, uh, that kind of takes area over. So 2D shapes, perimeter and area; 3D shapes, surface area and volume. Okay, so the surface area of a 3D sheet can be best seen by looking at a net. And this is a common term that you should, be, maybe you're familiar with, maybe you're not. But a net of a 3D shape is an object, and it's laid out in its depiction of, in a two-dimensional manner, of a 3D shape. So I'm giving you an example of a rectangle, in this rectangular prism. Okay, good examples of things that are rectangular prisms are, like, a cereal box is a really good example. Okay, um, some other things that may be three-dimensional prisms are, like, a textbook essentially takes on that shape when it sits there closed on the shelf. Many objects could be classified as being three rectangular prisms. Okay. And each rectangular prism has a length, a width, and a height, and they can be interchangeable. They don't always have to be exactly the same. Okay, so we can then draw them in a way that, if we were to fold them back out, lay them on the ground, we form what's called a net. So this is here what they call a net. Okay, this is an example of a net of basically this prism, or roughly, if we were reasonable about it. So what we have are the 3 dimensions that exist here. On here are, like, the length here is the length, and then this length would go all the way across. All of these things here would have the same measurement, of course, and then this might be considered the width, and then this over here the height. Okay, so this would also be the height, and then this would be the width here, and the width here, as they would kind of line up with each other as they go. So, and then I believe this is also, it's easy to get confused here. Whoops, I'm going to close this here. Oh, what did I just do? Clicked on the wrong thing. Minimize that. Okay, so this here is the width, of course, and this will be the height, and I believe that width times length, and so I believe this is your height and your length again. Okay, and so what you get is, a shape that you can fold together to make this rectangular prism, and we use that in particular to determine our surface area. So if I scroll down, my surface area is 2 length times width, 2 length times heights, and 2 WHs. So if you look around, this is a WL, and I believe there's another WL here. So there's 2 of them. And this is a WH, and this is a WH. So there's 2 of those. And then we're left with a HL here, and an HL here. And so you end up getting 2 of them. So there's 6 sides in total. And so if we add up one of each of those and multiply it by 2, we're good. We could also write this formula as 2LW plus 2LH plus 2WH if you would like. And that's just simply using what we referred to as our distributive property and applying that here. So if you recall that from doing our algebra unit where we use the distributive property, that would give us this formula version of it as well. It's either way works perfectly the same. Okay, so that's how we calculate the surface area of any three-dimensional object, is we basically lay it flat and we look at all the areas of each piece that comes to make or build it, okay? And we'll look at other shapes, or I'll at least show you other shapes and then leave you with a some homework to work on, okay? Now, volume is a little different. Volume is determined by the number of cubic shapes that can fit inside an object. And the most common one is a cubic centimeter, although I don't want you to think that that's the only one. There's cubic meters, there's cubic um, feet as well. Yards, cubic yards is used for concrete. So we still use some of the not, imperial system, but most of the stuff we're trying to do in this class will be using the metric, okay? And it uses this 1 centimeter cube. So this really is a cube that's made by 1 centimeter by 1 centimeter by 1 centimeter. And when we multiply them all together, we get 1 times 1 times 1, which is 1 centimeters cubed. We also refer to 1 centimeter cubed as a milliliter. So when you're buying your pop, or you're buying your Red Bull or whatever it is that you drink, and it says how many milliliters in it, maybe 746 milliliters. Well, that means 746 cubes this size. And a good example of what might be that size that you're familiar with, what might be a sugar cube. The sugar cubes, if you ever buy those boxes of sugar cubes, they come about 1 centimeter by 1 centimeter. I think they're a little bit smaller, but pretty close, okay? And if you have 1,000 centimeters cubed, or 1,000 milliliters, we refer to that as a liter, okay? 1 liter. And so that's where the volume is going. Now, when we're looking for volume of shapes, one of the things we almost always do is we look for the volume of the base, and then we multiply it by the height. So when we looked at a shape like this here, the base might be the length times the width. That would be the area of the base right there. And then we multiply that by the height, and that gives us our volume. So it becomes a three-dimensional shape. And so the volume of a rectangular prism would work out to being the area of the base times the height, which is the length times the width times the height. Now, there's a lot of different shapes that we can look at, and I'm going to show you essentially what is the formula sheet that's given to grade 9. So you're not asked to memorize all of these formulas. This is a formula sheet, and just to show you, the top half of the formula sheet shows you the perimeter and area of two-dimensional shapes. So we have rectangles, parallelogram, triangle, trapezoid, and circle. They don't put rhombus or kite on here, although I kind of like them. And one of the things I didn't really put a lot of focus on is that the area of a circle is pi r squared. But all these formulas are listed here. Probably you've seen most of these in your past education in elementary school. But when we get into secondary school, we also look at these three-dimensional shapes. And so we start with a cylinder, which is a round tube-like structure, and it's the area of the base times the height, and the total area, that's for the volume, area of the base times the height, and then that works out to this volume here. When we do the surface area, it's a little different. We have to break it apart into two different things, and sometimes it's really good to look up the net so you can see what a net looks like of this. And what a net will have is have a rectangle that is the sides, the curved sides, and two circles. And so you have two areas of the circle, and two areas of the base, and then the lateral surface area that is added to it. And here's the formula that they give you for that. And then we have the formula for a sphere. Okay, and this is quite unique, but it's 4 times pi times r squared. So 4 pi r squared is the surface area of a sphere. And don't ask me to derive it or where it comes from. It's just better if you just memorize it. And the volume is 4 pi r cubed divided by 3, or 4/3 pi r cubed. You can write it either way. And I like this formula sheet because it allows you to see it in both ways, okay? And this is a ministry issued formula sheet. By the way, I did not create it. It comes with the EQAO, and it could be used in an exam or whatever is necessary. Now we have the cone. The cone's a very interesting shape as well. We have a square base pyramid. You could also have really a triangular base pyramid, but we stick to square base pyramids, okay? And they have the volume here, formulas are written out, and the surface area is written here, and they break it into its individual pieces. So you have the area of each of the triangles, the 4 triangles, and you have the area of the base, which is b squared. Okay, and then finally at the bottom here they have the last couple prisms, a rectangular prism. There's the area we just looked at, as well as the area of volume here, surface area. And then finally, our triangular prism, and we have the surface area formulas written here and the volume uh, written here for a triangular prism. You are free to use this as you work on the worksheets that I've assigned you for this, so that you can calculate volumes of each things. And it's really just becoming familiar with how to do these things, okay? The answers that are provided, so if you're not getting it, you're not figuring it out, that's going to be a good time for us in a Teams meeting to work through, figure out what it is you're doing wrong, where things work in. Now, I thought I'd do at least one example, okay? Because, should do that. And that example I've chosen is a cone, okay? Because they're not the easiest and they're maybe not the hardest, but we can do them. So the cone shape you have is right here, and it shows a height of 18 and a radius on the bottom of 7. And that's really basically what you want to know for a cone. Those two measurements are required for a cone. Okay, now, in order to do the surface area, it's good to look at the net. This is what the net is. And it's kind of hard for you to see, but the actual radius here, it would be kind of halfway through here. And the circumference of this would be the distance across here. And you can see that that makes part of a circle, a portion of a circle. And what you probably need to know is this length here, which is not the height. Lots of kids think that's going to be the height, but it's not. The height is kind of this distance from the top of the cone down. This is the side length, okay? And we need to actually calculate the side length, and I'll show you where it is on here. This here is my side length, okay? And I want to find my side length. I have to treat this as a right triangle and use Pythagorean's theorem. And I'm sure you've used this before. It's something that is used all the time by students in grade 7 and 8 already, okay? And it's based on the formula a squared plus b squared equals c squared. So in this particular case, here is A, or I usually go A and B, and this is C, okay? And so I can substitute those in here and calculate for C. So I usually flip the formula right away and say C squared equals A squared plus B squared, and I'm going to calculate my S value. So C squared is going to equal 18 squared plus 7 squared. Now, I don't know 18 squared off the top of my head, but that's what calculators are for. So I can go 18 squared, and that equals 324, and add 49, which is 7 squared, and that gives me 373. Okay, so C squared equals 373. And the C then equals the square root of that, which is going to, basically, I'm going to square root both sides, because remember, the rule of solving equations is always whatever you do to one side, you do the same to the other. So I clear my calculator and I say square root 373, and I believe the answer comes out to 19.3. And I'll carry one extra decimal place along here. I don't go crazy with it, but add one more than is in the existing question is usually a safe bet, okay? So this tells me this is 19.3. And they don't say here, but let's just pretend they're centimeters, okay? That's an easy way to go. Now, I can start to calculate my surface area. And in order to do that, I'm going to go back to my formula sheet and grab the information on cones, right? And so there are two things. There's the surface area of the base and the surface area of the lateral surface. So that's the cone part, the curvature part, if you want to know. So if I go back here, pi r squared and pi rs, okay? So if I go back to here, just so you know, this is A1. We'll call this A1. It's pi r squared is going to be the surface area for it. And this is going to be A2, and it's going to be pi rs. Okay? So if I'm going to calculate my surface area here, I'm going to come back over here. I have two different things that I'm going to look for. Surface area is going to be area 1 plus area 2. Okay? Area 1 equals pi r squared. Area 2 equals pi rs. Okay? And that's essentially the two different areas that I'm looking at. So it kind of fits in line with doing, what do we call that? Those composite figures that we were looking at earlier. Okay? So area 1, I'm going to do equals pi 3.14 times 7 squared. And we can do that math quite easily using your calculator. 7 times 7 is 49, right? Times 3.14. And you don't have to do, like, put a special number in. If you want to use the pi feature in your calculator, you can, okay? And this comes out to 153.86. I'm gonna round it off to 0.9. Okay, I'm gonna just keep one decimal place, one more than what was given in my question. Since they had whole numbers here, I go to one decimal place on my answers here. Okay, if they had given me a decimal 1 here or decimal 2 for one of these, I would have done 2 decimal places. Just add an extra decimal place to what they do in the given question. Is a usually safe bet. Okay, so for area 2, I'm going to go 3.14 times the R value, which is 7, right, times the S value, which is 19.3. And I'm just using dots here to distinguish them. It's sometimes confusing. I wrote that a little bit small here. Let me write that a little better. That was terrible. I can do better. Equals 3.14 times 7 times 19.3. Okay, and now I can go and do that work in my calculator. It's pretty straightforward. So it's going to be 3.14 times 7 times 19.3, and that equals 424.2 if I round it off to one decimal place. Okay, and now my total surface area, I usually write SA equals A1 plus A2. Whoops, A2. I'm going to scroll down here, give myself a little bit more room. Okay, and what do I end up with? I end up with a value of SA equals 153. Oh, silly me. I put two sets of equal signs in there. Let me get one. 153.9 plus 424.2. And I just simply have to add those two numbers together. So again, grab my calculator. 153.9 plus 424.2 equals, and I get 578.1. And surface area will be centimeters squared. Okay, it's always a squared. It's like an area calculation, not a volume. So don't put area cubed on there. Okay, that gives us a surface area. Now we want to go and calculate my volume. Okay, so I'm going to look at my sheet for the volume formula for a cone, and the volume formula for a cone is right here. You can take it either way, this one or this one. the area of the base times the height divided by 3. So it's very similar to a cylinder where it's the area of the base times the height. But now because we go up into a cone, it actually is only 1/3 of the volume that a cylinder would be for the same length, which is weird. A lot of kids think it's going to be half, but it actually works out to exactly 1/3. So pi r squared times the height divided by 3 is the formula I need to do. So I write my volume formula out. Volume equals pi r squared h over 3. I find volume is actually quite a bit easier than the surface area. So 18 and 7 are the numbers I need to remember there. The radius is 7. So volume equals 3.14 times 7 squared times 18 all divided by 3. And this is one calculation that I can do all by itself, okay? And all in one foul swoop, I can punch it into my calculator. So 3.14 times 7 squared, or you can do times 7 times 18. And then you can say, I often just say equals. Sometimes I like to write that answer down. And then I divide it by, but you don't have to. Then you divide that by 3, and you get an answer of 923.16. 923.16. Now, 1/6 can round to 2, and that's what I do. I usually do one more decimal place than what's given in the question, and my units are centimeters cubed, okay? I could write them as milliliters, it all depends, okay? And then I box off my answer. It's really that simple. Use the formulas that are given and plug the numbers in. Recognize what they're doing. A little trickier with the surface area questions, but not crazy. There's a bunch of questions for you to work on. Practice makes perfect here, folks. Don't think this is so easy and you don't need to do it. I find a lot of kids kind of get a little bit complacent with this, and then when it comes to doing an evaluation or a test or something, they go, "Oh, I screwed this up or I screwed that up." So do a few practice questions. You'll find it goes a long way in helping build your skills. All right, we'll see you next time.